Evaluate the cosine of 2 times tangent inverse of 2/3. Right, now this problem looks a little bit tricky, right? A little bit complicated. But if you break it down, right? Let's take a look, right? So we see this tangent inverse of 2/3, right? Remember, if this is the inverse tangent function, right? If tangent inverse of 2/3, right? Now this has to equal some angle, right? What this is saying is that the tangent of theta is equal to 2/3. So we can really rewrite the original question as evaluate cosine of 2 theta, where theta is given by this, the tangent inverse of 2/3. But we notice the 2 here, right? That tells us that this is a double angle formula for cosine. And what is a double angle formula for cosine? Well, there's actually 3 of them, right? There's actually 3 double angle formulas for cosine. So we're just going to use this one, okay, cosine squared theta minus sine squared theta. And now remember, this is a formula, right? So in the formula, what do we want to plug in? We want to plug in the cosine of theta, whatever that is, and then square it. And then we want to plug in the sine of theta, whatever that is, and square that. So how are we going to find cosine of theta and sine theta? Right, we're going to get that from this, right? We know that the tangent of theta is equal to 2/3, right? So if you want to draw the triangle, we can, right? Tangent is opposite over adjacent, or y over x, which means the opposite side here is 2, right? Which makes this side here 3. So what's the hypotenuse going to be? Well, the hypotenuse, we can find that, right, using the Pythagorean theorem. 3 squared plus 2 squared. 3 squared plus 2 squared is 13. So r is going to be the square root of 13, right? So then what does that make cosine of theta? Well, cosine of theta is 3 over radical 13, which makes the sine of theta then 2 over radical 13. And notice that these are the 2 values that we're just going to plug into the equation, right? Now, the radical is on the denominator, but I'm not going to rationalize, right? Because I notice I'm going to square these anyway, right? So what do we get for the final answer? Okay, notice we got to plug in the cosine of theta, which is 3 over radical 13, and then square that, minus the sine of theta, right? So it's going to be 2 over radical 13, and then square that. Well, what is 3 over radical 13 squared? Right? 3 squared is 9, radical 13 squared is just 13. Similarly, 2 squared is 4, radical 13 squared is just 13. So what's the final answer here then? Right? Combine these terms together, we get 5 over 13 as the final answer.